Welcome to our educational overview of chemical engineering. In this video, we'll explore the principles, processes, and applications that define this fascinating field. Chemical engineering is more than just chemistry and engineering combined. It's a discipline that profoundly impacts various industries and our daily lives. From developing sustainable technologies to improving production efficiencies, chemical engineers play a critical role in solving some of the world's most pressing challenges. We'll dive into core principles such as mass and energy balances and examine real-world applications like pharmaceutical manufacturing and renewable energy integration. We'll also explore key concepts underlying different chemical processes and highlight innovations driving the future of the field. Whether you're a student beginning your journey or a professional looking to expand your knowledge, this video provides valuable insights into the world of chemical engineering. Stay with us as we uncover the intricacies of chemical engineering, giving you a comprehensive understanding of what to expect in the modules ahead. Let's begin this exciting journey into the heart of chemical engineering. Welcome to the first module of our journey into the world of chemical engineering. Here, we'll delve into the fundamental principles that serve as the bedrock of this dynamic field. Understanding these principles is essential for grasping the more complex concepts we'll explore later. So, let's start with the basics. From the laws of thermodynamics to mass and energy balance, these core concepts are the building blocks of the entire discipline. They enable us to design, analyze, and optimize various chemical processes, ensuring efficiency and sustainability in industrial operations. These principles aren't just theoretical. They have practical applications influencing sectors from pharmaceuticals to energy production. Mastering these fundamentals prepares you to tackle challenges and opportunities in your chemical engineering journey. As we progress, you'll see how these principles are implemented in real-world scenarios, highlighting their importance. Stay with us as we explore the key concepts unlocking the mysteries of chemical engineering. To understand mass and energy balances better, let's examine a real-world example, an industrial chemical plant, a hub where these principles come to life. First, we consider mass balance, ensuring the total mass entering and leaving the system remains constant, which is vital for efficiency and minimizing waste. Next, we delve into energy balance, tracking energy input, output, and transformations within the process. Accurate energy management is crucial for optimizing production and reducing costs. In our case study, we'll explore how these concepts are meticulously applied, enabling the plant to operate sustainably and effectively. As we move forward, you'll see the tangible impact of these principles on industrial operations and the broader field of chemical engineering. Chemical processes are at the heart of chemical engineering, spanning various types, each designed for specific industrial applications. From distillation to reaction engineering, and from extraction to crystallization, each process plays a vital role. Understanding these processes' design is crucial for efficiency and effectiveness. The design phase involves meticulous planning and consideration of factors such as raw material properties, energy input, and desired output. But design is just the start. Optimization elevates a process from functional to exceptional. Enhancing efficiency, reducing waste, and minimizing costs are pivotal aspects of process optimization. Techniques like process simulation, advanced control systems, and real-time monitoring help achieve these goals. By optimizing processes, we improve productivity and contribute to sustainability and environmental stewardship. As we dive deeper into this module, we'll explore specific case studies and examples illustrating these concepts further. Chemical processes are engines driving industrial innovation and development. Moving forward, you'll see detailed examples of these processes in action and their industry impact. Distillation is a key process in chemical engineering, involving separating components from a liquid mixture through boiling and condensation. Today, we'll dive into a real-world case study to see how companies utilize distillation on a large scale. We'll explore the distillation process at a major petrochemical plant, observing how crude oil transforms into valuable products like gasoline, diesel, and jet fuel through multiple stages of distillation. Each stage targets specific components, enhancing efficiency. We'll also discuss optimization techniques used to boost efficiency and reduce costs. For example, the plant uses advanced control systems to monitor and adjust temperatures precisely, ensuring maximum yield from each batch. Heat integration strategies recycle heat energy, significantly cutting energy consumption. By the end of this segment, you'll have a comprehensive understanding of how distillation works in an industrial context and its role in converting raw materials into everyday products. Let's continue our journey into the world of chemical engineering processes. Engineering principles form the foundation of chemical engineering. Concepts like fluid dynamics, heat transfer, and material science are essential for solving complex industrial problems. Fluid dynamics helps understand the behavior of liquids and gases in various systems, ensuring efficient transport and processing. Heat transfer principles are crucial in designing processes where temperature control is vital, such as in reactors and cooling systems. Material science guides the selection and development of materials that can withstand harsh chemical environments and high temperatures. Together, these principles enable chemical engineers to design effective and efficient processes. As we delve deeper, we will see how these principles apply to real-world scenarios, tackling industrial challenges. Get ready to uncover the intricate applications of these engineering principles in the upcoming segments, and see how they drive innovation in chemical engineering. Heat exchangers are crucial in many chemical processes, efficiently transferring heat between fluids. In our case study, we delve into heat exchanger design specifics in an industrial context. Design must consider factors like fluid properties, flow rates, and temperature differences for optimal performance. This case highlights these design principles' application in a large-scale chemical plant, focusing on the heat exchanger's integration and operation. Innovative design and material choices significantly enhance the system's overall efficiency and reliability. As we explore this case, we'll see how theoretical principles translate into practical solutions, presenting both challenges and opportunities for improvement. From initial design considerations to final implementation, this case study exemplifies the complexities and rewards of chemical engineering. Moving forward, we will uncover more industrial applications and design strategies defining this fascinating field. Chemical engineering profoundly impacts various industries, from pharmaceuticals to energy and food processing. By transforming raw materials into valuable products, chemical engineers optimize processes and drive innovation. Today, we'll dive into key industrial applications of chemical engineering, exploring how advancements shape the pharmaceutical industry, make energy production more sustainable, and revolutionize food processing methods. Future trends indicate more groundbreaking developments, such as enhanced process automation and artificial intelligence integration to streamline operations. As we move forward, you'll see how chemical engineering meets various industries' demands today and paves the way for a more efficient, sustainable future. Join us as we uncover the significant impacts and exciting future trends of chemical engineering across these vital sectors. Pharmaceutical manufacturing is intricate and demanding, heavily reliant on chemical engineering principles. Through this case study, we'll delve into the myriad challenges faced in this industry and uncover innovative solutions. Chemical engineering ensures pharmaceutical processes are efficient, safe, and scalable. Maintaining precise chemical reactions and purity levels is crucial to producing effective medications, but achieving this comes with hurdles. Engineers tackle issues like reaction control, contamination risks, and process optimization. Their expertise and advanced engineering principles yield solutions. In our case study, we'll explore instances where chemical engineering tackles such problems. Engineers optimize pharmaceutical processes, adjusting reaction conditions and implementing cutting-edge purification techniques. The result is improved efficiency and greater product consistency and safety. As we move forward, you'll see these solutions implemented in real-world settings, showcasing chemical engineering's critical importance in transforming challenges into opportunities in pharmaceutical manufacturing. Chemical engineering is at the forefront of solving some of the world's most pressing environmental issues. The field focuses on efficient processes and considers its ecological footprint. Sustainability is integral to modern chemical engineering, guiding the development of cleaner, greener technologies. Waste reduction techniques and renewable energy integration are just some innovations aiming to minimize environmental impact. Recycling byproducts and harnessing eco-friendly materials further contribute to sustainability. The circular economy concept, where waste from one process becomes raw material for another, reduces waste and conserves resources. Advancements in catalytic processes enable more efficient reactions with less energy and fewer emissions, impacting everything from water purification to air quality management. As we move forward, you'll see specific examples and success stories of how these sustainability practices are transforming industries and paving the way for a cleaner, sustainable future. Stay tuned as we explore innovative solutions shaping a greener tomorrow. Integrating renewable energy sources is rapidly becoming a cornerstone in chemical engineering, where the discipline's principles and the need for sustainable practices converge beautifully. Today, we delve into a case study highlighting this integration. We'll explore how chemical engineers blend renewable energy solutions into their operations, creating real-world success stories. From harnessing solar power to utilizing wind energy, these innovations revolutionize the field and pave the way for a more sustainable future. By examining this case study's details, we'll witness renewable energy's transformative power in chemical processes. Chemical engineers spearhead these efforts, developing methods maximizing efficiency and minimizing environmental impact. These success stories stand as a testament to chemical engineering's pivotal role in achieving a sustainable energy landscape. Moving forward, you'll see how these examples set the stage for even more groundbreaking advancements in the field. Let's continue our journey to uncover the many facets of chemical engineering and its profound impact on our world. As we step into the future, chemical engineering continually evolves, bringing new and exciting trends. Technological advancements drive this transformation, spurring progress and innovation. The landscape rapidly changes from artificial intelligence in process design to developing sustainable, eco-friendly materials. Imagine chemical processes optimized in real time using big data analytics or bioengineering leading to pharmaceutical and healthcare breakthroughs. These emerging trends are tangible realities shaping our world. The future outlook for chemical engineering is bright, filled with opportunities for advancement and the potential to solve humanity's most pressing challenges. The synergy between technology and chemical engineering will pave the way for groundbreaking innovations. Having explored this dynamic field's trajectory, let's delve into a cutting-edge case study on advanced materials, showcasing the innovations set to revolutionize chemical engineering. Advanced materials are revolutionizing chemical engineering. In this case study, we'll dive into innovations pushing boundaries and creating new possibilities. These materials, with their unique properties, not only enhance efficiency but also drive sustainability in myriad applications. From aerospace to healthcare, adopting advanced materials has a significant impact. They've paved the way for lighter, stronger, and more resilient structures and led to breakthroughs in medical devices and renewable energy solutions. Imagine aircraft wings that are both lighter and stronger, or medical implants that are more biocompatible and longer-lasting. The transformative power of these materials lies in their molecular-level engineering. By manipulating their structure, chemical engineers create materials that can withstand extreme conditions, self-heal, and even adapt to their environment. These innovations reshape industries and set the stage for a more advanced, sustainable future. As we conclude this segment, reflect on the profound influence of advanced materials. Their ongoing development promises to unlock new frontiers and solve some of our most pressing global challenges. In our final segment, we will summarize the key points discussed and highlight the importance of continuing to explore the fascinating field of chemical engineering. Stay with us. We've covered a lot in this video series. From fundamental principles to real-world applications, we've seen chemical engineering's profound influence on various industries. The processes and technologies discussed are not just fascinating but vital to our modern world. If you're inspired by what you've learned, I encourage you to delve deeper into this incredible field. The journey of exploration and discovery in chemical engineering is just beginning for you. As we move forward, consider how you can contribute to advancing this essential science. Thank you for watching. If you enjoyed this video, please subscribe to our channel and explore more content on chemical engineering. Stay connected with us for more insightful topics, case studies, and real-world applications. Your support helps us continue to provide quality educational content. See you in our next video.